Have you ever wondered what protects our planet from the relentless onslaught of the solar wind and cosmic radiation? Think of it as a cosmic force field, an invisible shield that stands guard between us and the menacing threats of the cosmos. This shield is what we call a planetary magnetosphere. In the cosmic theater, there are two main villains, the solar wind and cosmic radiation. The solar wind, a constant stream of charged particles belched out by the sun, hurtles through space at a mind-boggling speed of 1,000,000 miles per hour. Cosmic radiation, on the other hand, is composed of high-energy particles from far-flung corners of the universe, traveling at speeds close to that of light. These cosmic threats, if left unchecked, could strip away a planet's atmosphere, drastically altering its surface conditions and making life as we know it impossible. Now enter our heroes, the planetary magnetospheres. These are magnetic fields surrounding planets, acting like invisible shields. They deflect and divert these harmful solar and cosmic particles, protecting the planet's atmosphere and surface from the ravages of space weather. In our solar system, these magnetospheres are as diverse as the planets themselves. From the powerful magnetic field of Jupiter, which could hold about 14 Earths across its diameter, to the weaker fields of Mars and Venus, each magnetosphere tells a unique story of planetary evolution and survival in the harsh cosmic environment. So, while we go about our daily lives blissfully unaware, these planetary magnetospheres are constantly at work. They bear the brunt of the solar wind, absorb the shock of cosmic radiation, and mitigate the impacts of space weather, all to ensure that our planet remains a safe haven in the otherwise harsh, inhospitable universe. So these invisible shields, these planetary magnetospheres, are the unsung heroes in the cosmic drama of survival. But how does a planet come to possess such a powerful shield? Let's journey deep into the heart of a planet, where the story of a magnetosphere begins. It all starts with a process known as the Dynamo Effect. Imagine the core of a planet, a swirling, churning cauldron of molten iron and nickel. As this molten mixture moves and flows, it generates electric currents. These electric currents, in turn, give rise to magnetic fields. It's a bit like how a dynamo in a bicycle generates electricity as the wheel turns, hence the name Dynamo Effect. This magnetic field, born in the fiery depths of a planet's core, extends outwards, enveloping the planet in its protective grasp. But the story doesn't end there. This magnetic field, once generated, isn't just a static bubble. It's dynamic, constantly shifting and changing due to the energy and particles streaming out from the sun. This stream, known as the solar wind, is a potent force, carrying with it both light and charged particles. When the solar wind meets a planet's magnetic field, it doesn't just stop in its tracks. Instead, it shapes and molds the magnetic field, stretching it into a teardrop shape. The side of the planet facing the sun has a compressed magnetic field, while the side away from the sun has an extended trailing magnetic field. This interaction between a planet's magnetic field and the solar wind gives birth to what we call a magnetosphere. The magnetosphere, then, is not just a shield, but a living, breathing entity, born of the dynamo effect within a planet's core and shaped by the solar wind. It's a testament to the incredible forces at work in our universe, forces that protect life on our planet and shape the conditions on other worlds. And so, deep within the heart of a planet, a magnetosphere is born. Yet, not all shields are created equal. Just as planets in our solar system vary in size, composition, and atmosphere, their magnetospheres also exhibit a fascinating diversity. Take Jupiter, for instance. This gas giant boasts the strongest magnetic field among the planets, a staggering 20,000 times stronger than Earth's. This colossal magnetosphere extends far into the solar system, reaching beyond the orbit of Saturn. It's so powerful that it traps a belt of charged particles around the planet, creating dazzling auroras at the poles that are even more spectacular than our own northern and southern lights. But turn your gaze to Mars and Venus, and you'll find a starkly different picture. Mars, our red neighbor, has a weak and patchy magnetic field. Its magnetosphere is not strong enough to shield the planet from the solar wind, leading to the gradual stripping away of its atmosphere over billions of years. As a result, Mars is a dry, barren world, with surface conditions hostile to life as we know it. Venus, despite being similar in size and composition to Earth, also lacks a global magnetic field. But its dense atmosphere, packed with carbon dioxide, creates a sort of indirect shield against solar radiation. Still, the lack of a robust magnetosphere means that Venus is exposed to solar wind, leading to a superheated surface and a runaway greenhouse effect. These examples illustrate the crucial role that magnetospheres play in shaping a planet's environment. A strong magnetic field, like Jupiter's, can create a spectacular light show and protect the planet from solar radiation. A weak or non-existent one, like on Mars and Venus, can lead to atmospheric loss and extreme surface conditions. As we can see, the strength of a planet's magnetic shield can be a matter of life or death. Each planet's magnetosphere, or lack thereof, tells a unique story, influencing its ability to support life and shaping its interaction with the cosmos. What happens when these mighty shields meet the fury of solar storms? Well, imagine a scene out of a cosmic battlefield. On one side, you have the planetary magnetospheres, these invisible shields that protect our planets. On the other side, you have the solar storms, these intense eruptions of energy from the sun. Now, solar storms aren't your typical weather event. They are massive explosions on the sun that send charged particles hurtling through space at incredible speeds. These storms can take the form of solar flares, which are sudden bright flashes of radiation, or coronal mass ejections, which are giant clouds of solar plasma flung into the cosmos. And when these particles reach our planet, they interact with our magnetic field, causing a disturbance known as a geomagnetic storm. So, what happens when these cosmic forces clash? Well, you get a celestial light show for starters. The interaction between the solar particles and the magnetic field triggers the spectacular auroras we see at our poles, the northern and southern lights. But it's not all beauty and wonder. These storms can also pose serious threats. When solar storms hit, they can cause temporary disturbances in the Earth's magnetosphere. These disturbances can result in changes in the Earth's electric field, which can interfere with our technology. Power grids can fail, satellite communications can be disrupted, and navigation systems can go haywire. And it's not just our technology that's at risk. Intense solar storms can also strip away a planet's atmosphere over time. For instance, Mars, with its weak magnetic field, has lost much of its atmosphere due to solar storm activity, a harsh reminder of the vital role magnetospheres play in planetary survival. But despite these challenges, our magnetic shield holds strong, protecting us from the majority of the harmful solar radiation and cosmic particles. It's a silent guardian, a tireless protector, a cosmic titan in its own right. In the face of such cosmic fury, the magnetosphere stands as our planet's first line of defense.
How do we know all this about these invisible shields, you might ask? Well, we owe much of our knowledge to recent discoveries and observational missions studying planetary magnetospheres. Thanks to the tireless work of scientists and engineers, we've launched a number of spacecraft into the cosmic wilderness. Consider Voyager, a veritable elder statesman of space exploration. Launched in the late 70s, these twin spacecraft voyaged to the outer planets, collecting priceless data about their magnetic fields. Then there's Galileo, which spent 8 years orbiting Jupiter, studying its intense magnetosphere in unprecedented detail. And let's not forget Juno, still currently orbiting Jupiter, revealing new insights into the gas giant's powerful magnetic field. Each of these missions has contributed invaluable data, helping us better understand the complex dynamics of these invisible shields. And as technology advances, we'll continue to delve deeper into these cosmic mysteries. Through the eyes of these spacecraft, we are beginning to unravel the mysteries of these cosmic shields. So why should we care about these invisible shields? Well, imagine a world without its magnetosphere. The harmful solar radiation and cosmic particles would strip away the atmosphere, rendering the planet inhospitable for life as we know it. Planetary magnetospheres are not just fascinating phenomena, they are integral to our understanding of planetary science and essential for space weather forecasting. Understanding the dynamics of these magnetic fields can give us valuable insights into the nature and evolution of planets, even the potential for habitability. For instance, the absence of a significant magnetosphere on Mars might explain its thin atmosphere and lack of liquid water on the surface. Furthermore, as we venture further into space, knowledge about magnetospheres will be crucial. They can protect spacecraft from damaging radiation, making interplanetary travel safer and more feasible. So, in essence, these invisible shields are our allies in the quest for cosmic exploration. As we journey further into the cosmos, understanding these invisible shields may well be key to our survival in the cosmic ocean.